Hi, I'm Ruchi. I'm a GDG ambassador and organizer for the community of New York City. Welcome to the AI, ML, and the basics and why we need your involvement. I would like to welcome our next speaker, Carolyn Ujik, who heads and leads Services America's global practice at Google. I met Carolyn at a cloud workshop before the pandemic. Carolyn has been a Googler for over 11 years and has made tremendous impact within the community. It is my pleasure to welcome you to the Lightning Talk with Carolyn Ujik. Welcome, Carolyn.
Thank you so much, Ruchi. I'm thrilled to be here and to speak to all of you today. So I'm going to go over a very quick presentation on AI and ML, the basics, and why we need your involvement. So hopefully I'll inspire you a little bit with some of the content. Also encourage you to think maybe a little differently about the role you can play with AI and ML as you might evolve your careers in that direction in what you're doing today in tech. All right. So I'm going to go ahead and get started. As Ruchi mentioned, I've been at Google for over 11 years. I'm part of our Google Cloud organization, and I lead a team in the Americas that provides consulting services for customers who want to do AI and ML projects on Google Cloud. And this has been a great opportunity for me. The role didn't exist when I joined Google, so I've definitely had kind of a strange path to get here, but it's been an amazing opportunity. I'll tell you a little bit about what that means, give you an example of our customer work, and then I will also talk to you a bit more about responsible AI and your role in responsible AI going forward. All right, so I just want to level set with a basic definition of machine learning. I know not everyone here is a data scientist or ML engineer, so we're going to start with that. So the definition that I like to use is ML is a way to get predictive insights from data to make repeated decisions. Now that may sound a bit complicated, but each part of that definition is really important when you think about ML. So you can think of it kind of like a recipe, and each of these are important ingredients. So think about what you do today for work. Think about the business that you're a part of. How do you use data today? Do you have a dashboard that you might check every day to see how things are going, to monitor maybe things that are in progress? Or do you have a report that maybe you're preparing for your manager on a monthly basis? So when you think about those examples, those are all examples of backward-looking data. So most analytics that you're doing today in your business is probably backward-looking data, where you're looking at historical data to calculate metrics or to identify trends. But if you really think about where you can create value and your organization can create value, you need to use that data to make decisions. So it's not enough to identify a trend, you really need to make decisions based on that trend. All right, so switching gears, both those dashboards and support are examples of that backward-looking data, but what AI and ML really focuses on is that forward-looking data. So I'm going to talk you through an example just to illustrate that a little bit more. So imagine you're reviewing a report as an analyst and you see demand is increasing for a certain product. Maybe toilet paper is really taking off in a specific region. So as an analyst, you might take a look at that price and suggest, hey, maybe we should change the price here due to increasing demand to increase profit. So now that is an example of a predictive insight. But is that scalable? If that's your job, can you really make those types of decisions every second for every product in every region? No, that's pretty much impossible, right? But that's where you can use technology to scale. And that's one way that AI and ML can help. So again, if we go back to that definition, you need those predictive insights that we just talked about, those forward-looking insights, to make decisions in a repeatable way at scale. And computers can help us to derive those insights. So think of machine learning as a tool that's going to enable you to make those predictive decisions from data and scale your business intelligence and decision making. All right, so hopefully we're grounded in that definition I'm going to give you a few more examples about how machine learning is working. And again, this will tie into the responsible AI piece that I really want to make sure we take some time to talk about at the end. Okay, so if you take a look at what's on the slide, you'll see standard algorithm. Machine learning uses standard algorithms. And normally when you think of computers or you think of the software that you might be working on, you might use software to do different things. You might have a program you use to file your taxes, and then a different program that you use to get directions home. But machine learning is a little bit different. You can almost think of those standard algorithms as software, and you can use the same software to do very different things. So you might use the same standard algorithm to estimate taxes, or you can also use that algorithm to estimate the time that it might take to get home. So think about it that way when you're thinking about how ML can be used. And once that software is trained for your specific application, that's termed a model. And again, you'll see that listed on that slide. So whenever we're doing machine learning, we need to train a model with many, many examples. It's a little bit of an oversimplification, but for the majority of cases, this is the way that it works. So we would train a model to estimate taxes by showing it many examples of tax returns. And we would train a model to estimate a trip duration by showing it many, many journeys. So again, in many cases, that's the very first step of AI and ML. And an example consists of a few things, and you'll see it on the slide here. But we've got our examples, you'll see the different shapes, and each of those has a label. So that's the correct answer, if you will, for that specific example. So imagine if you're working at a manufacturing company and you want to train your model to identify defects in parts that maybe are assembled into products. So you'd collect a data set of images of those parts. Some will be good, some will be defective, and for each image, you would have a corresponding label for that example. All right, and then what's cool about machine learning is after you've trained that model, you can use it to predict the label of images it has never seen before. So again, you can show it an image of a part, and it's going to be able to correctly predict if that part is in good condition. And note on the slide, the parts that we have, the shapes that we've illustrated, they look different than the previous ones, but that's because the model can now generalize to other examples. All right, and so the key to making that model able to generalize is to give it lots and lots of data. So you can see here on this slide, we have a few examples of standard use cases. Again, maybe you can start thinking, get your wheels turning about how you might use these different use cases in different ways. So you might be detecting a pattern in image. Maybe that's for some sort of healthcare diagnosis, or it could be for manufacturing. Maybe you're trying to predict the future of a time series. So again, what is the demand going to be next week and then the following week as well? And you can also use machine learning to understand or transcribe speech or text. So many, many different applications. Again, a lot of opportunity for you as you grow in your careers and as this technology continues to advance. So now I'll briefly talk about an example of some of the work that my team has done with some of our customers. So this is just one example. We work across many, many different industries, but we worked with Roostify, and they are a home loan company. And we really help them to digitize and automate a lot of parts of the mortgage process that can really slow things down. Again, so we worked with them very closely. We identified their use case, tried to understand what data they have. We also were able to bring some of our Google technology. We do have some pre-trained models that you can use to accelerate things. But in many cases, there's a little bit of customization that you need to kind of get things right. And so Roostify was a company where we were really able to come in and use a pre-trained model related to Lending.ai and fit that into their business process so that they could make decisions faster, but again, in a responsible way. And we'll talk more about that on the next slide. But lots of really exciting career opportunities with AI and ML. So definitely would encourage you all to take a look at it as a potential next step in your career path. Because it's so new, there's always something to learn. There's a lot of opportunities for folks to come in and learn who might have non-traditional career paths. So I had that experience. And again, I'm hoping you all might see that as a next step in your career and be able to help with this area of huge potential in technology. So now we'll talk briefly about responsible AI And then hopefully we'll have a little bit of time for questions. If not, I'm happy to chat in the Slack, or you can connect with me on LinkedIn. But responsible AI is something that's really important to me personally. It's an area of work that I really appreciate, enjoy, and find to be incredibly complex. So at Google, we have a list of AI principles for how we want to work with AI and ML technology. Because as you know, technology can be an extremely powerful tool for many different things, and it can be used for good or not so good. So on the slide on the left, you'll see a list of green numbers, and those are our AI principles. So we try to align the work we do and assess it against those AI principles. I'm not going to read through them all, but there's a lot of great information on our approach to responsible AI that's on our site as well. So that's something else you can take a look at. We also have a list of applications we will not pursue. So again, these are ways that we basically expect technology could be used not for good, and so we don't want to be involved in those. So I'd encourage you, especially as you build a career in AI and ML, to really stay focused on responsible AI and think about, again, in your organization, what are your organization's AI principles and how do you want to put those into practice? Okay, so I'm going to take you through some more information about how you can do AI responsibly, especially as you get more involved in that in your work. So one, use a human-centered design approach. You may have heard about this before, but again, this is even more important with AI and ML. You need to think about how your users are going to experience that technology. How are they going to experience those predictions, those decisions? So AI can make things much better for humans in many ways, but again, you want to always take that human-centered approach to design as well. So you also want to know your training data. And again, that's why I walked you through that example at the beginning, because you want to make sure that your machine learning model is able to predict. And largely, the way they predict is a reflection of patterns in the training data. So understand any limitations that data might have. Again, is it representative? Do you have enough examples of a particular subclass or subgroup of what you're trying to predict? And there's a lot of patterns in the data that aren't always obvious to us as humans. And those patterns can reflect societal norms, practices, and biases. So knowing they are there can really help you decide what to do. And again, I think many of you, with your focus on allyship, with being a woman working in tech, are probably in a unique position to help us really spot and understand some of those biases and some of the issues that might be present in your training data. And then finally, the last thing is interpretability. So treat that as a core part of the experience. Why did the model make a specific prediction? So again, we want to make sure that things are explainable, and it's explainable in a way that a human can understand. And we're building a lot of cool tools related to interpretability and explainability to make that easier, and again, help you to do AI more responsibly. I know we're almost out of time, but want to close with this slide. Technology, again, really important, really powerful. I'm excited to see so many of you playing a role in technology and how we're using it around the world. But it's something that is very powerful, and we want everyone to be able to benefit from that. And that's why these responsible AI discussions and these topics are so important. And again, I think you need to play an important role in how we use that technology going forward. So responsible AI is successful AI. And finally, I'll close with a few other resources. So hopefully, again, I've inspired you to explore ML a bit more in your career. And if you're getting started and want to explore more, there's a great data scientist and machine learning engineer learning path available from Google Cloud. So you can check that out, as well as once you're getting a little bit more experienced, or maybe you have been working in the field for a little bit longer, there's an ML engineer certification you can take part in. So thanks so much for letting me present today. And I hope, again, I've given you some new information, that I've inspired you. And I'll turn it back over to Ruchi. I think we may have time for a few questions, but if not, again, hit me up on the Slack, connect with me on LinkedIn. Happy to chat more.
Carolyn, thank you so much for sharing and inspiring our community here with a lot of the predictive decisions and standard algorithms and some of the use cases that you shared. We do have some questions coming in. I noticed one from Navatat. I'm sorry if I'm not able to pronounce it correctly. Navati, how do you tune the algorithm? What kind of expertise and strategy do you need to play around with these parameters of the algorithm?
Yeah, that's a great question. And I know we're a little crunched on time, so I'd love to talk to you more about that, Naviti. And we have a lot of great tools in cloud to help you do that on Google. So I'm happy to speak to that a bit more. It does depend on the algorithm you're using, but there's a lot of great, I would say, best practices that I can share with you around that.
I think we have time for one more question that's coming in from Dan. Real world problems tend to be less clear cut than image classifications. For example, how do you predict using somewhat fuzzy data?
Yeah, that's a great point, and what you point out is spot on. So, real world problems are less clear cut. And we talked about the importance of knowing the limitations of your data and the training data that you have. So that's really critical, and that's an early step in any ML project. You want to make sure that you take a look at your data. Is it high quality, right? Does it represent the things that you want to? And there are some strategies that you can use to collect additional data or to maybe enhance your data. So again, happy to chat more about that. I know we don't have a lot of time. So Dan, maybe we can connect on Slack, and you can tell me a little bit more about your specific question and maybe that specific scenario that you're thinking of.
Carolyn, thank you so much. Dan, thank you so much for asking that question. And yes, we can connect on Slack. And that brings us to um, uh, Nicole Benson.